Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. And in this time, I want to show you a feature that is very used in many service provider environments, even not only service provider, but also small, medium networks, enterprise network, or even networks that are like service provider network. So there are many enterprise networks that have a core of MPLS, of segment routing, of SRv6, and they obviously provide services. So this feature is very useful for all this type of environment, specifically targeting SRMPLS and SRv6 technologies. Okay, and the feature of course that we have is TI-LFA. TI-LFA, it has by name topology independent LFA. Okay, and the simple concept and the simple, let's say, word or statement that we can say about this feature is to provide fast convergence during a failure scenario. Okay, basically this feature ensures that there will be a backup path, or let's say better active path, whenever a failure will occur. Okay, that's the intention of TI-LFA specifically. Why is important to have this feature? Well, when there is a failure link in a network, so for example we have this scenario that is here, a triangle, SRNIK1, SRNIK3, SRNIK2, so they are connected in this manner. When there is a failure of the link, the router, if we are running for example OSPF or ISIS or even any protocol, right, the router needs to select the best path because the main path went down, right? If for example ASR9K1 want to reach, let's say, the loopback 0 of ASR9K3, so ASR9K1 probably use this path as a best path and it use this path as a backup path. Probably this path as a best path because it's the closest one to the ASR9K3, and the other because of course it's the longest one. So in this scenario, if there is a failure of this link, like is in the red screen that you see there, then basically the router needs to run an SPF algorithm. If it's a link state protocol like ISIS or OSPF, it needs to run an SPF runtime and trying to find a backup path for the loopback 0 destination of ASR9K3. Okay, and that process of finding a backup path and run the SPF and insert the backup path then later into the CEF or FIP, that process is taking a bit or a lot of convergent time, of course, depending of the network size, depending of the amount of routes that is in the network, depending of the capacity of the device as well. It depends of several factors, but the point is that TI-LFA save us time by not running the SPF algorithm, choosing the best path, and then inserting that into the FIP and CEF. Sorry. Okay. So that's the normal process that a router, in our case ASR9K1, had to go. He has to, of course, first figure out that the link fell down, then run the SPF, then choose the best path, after the failure, and then insert that into the FIP. And all of that process, especially running the SPF and choosing the best path, might take even seconds of time depending of how the network looks like and how the network is scaled. Okay, so that's how normally is, and TI-LFA, again, as we mentioned, it avoids to do all of that. It avoids to run the SPF, it avoids to put to spend time in putting again the route into the FIP and CEF. What TI-LFA does is basically it reacts into the failure. So when the failure occurs, the router already, before even that the failure occur, the router install the best path. That is, of course, the link directly to ASR9K3. In this case, we are again taking the scenario between the loopbacks. The ASR9K1 installed into CEF, and it ran the SPF algorithm, of course, before the failure now. It found the best path, it installed the best path into CEF, and here you will see ASR9K3 as a next hop. But also, if we have TI-LFA enabled, ASR9K1 try to find if there is another backup path or another way to reach out the loopback 0 of ASR9K3. And then, of course, he founds, because the backup path and the other link to reach the loopback 0 of ASR9K3 is through ASR9K2. So it finds the path, it calculates as well the cost and everything, and also insert that backup path into Ceph. So TI-LFA ensure that ASR9K1 will have into Ceph the best path and also the backup path. In this case, when a failure scenario occurs, so the best path goes down, of course, because the link will down, then the backup path will be alive and the traffic will keep moving and being forwarded across the network. Okay? So that's the intention of TI-LFA, having a backup path into Ceph and FIP and avoid the calculation of SPF and then inserting into Ceph. That of course it can take a lot of time, and instead of that the route is already inserted into Ceph and then the router have a backup path to reach out the target destination. Okay, that's in a nutshell what TI-LFA does. There is of course a way of how it calculates the backup path as well. It's a bit complex, and we might need probably a long video for that, so I will not explain that. But what I can say is that TI-LFA, by the statement of topology independent, that is TA at the beginning, so this topology independent means that the router and every device in the network calculate a backup path for every prefix independent of the topology. Okay, doesn't matter if you have a super higher cost in the backup path than the best path, because HRP has those parameters as well and requirements for choosing a backup path, for example. HRP is particularly in that. But TI-LFA, because it's topology independent, it can calculate a backup path for every prefix in the network as far as you have another link to reach out to that particular destination. Okay, so that's a particularity of TI-LFA. Okay, it shows the backup path in any situation. Okay, so that's what I wanted you to take out from that concept. Okay, as far as we have a second link to reach out the destination, it chooses a backup path for that. And TI-LFA, last thing that I will mention during these theoretical concepts of all these backup paths and stuff, come from the family of the LFAs. Okay, LFAs is a concept of having a backup path for a particular destination. And within LFA, we have, of course, the plain LFA that we all know, LUT-free alternate. We have remote LFA that is used exactly the same use case as TI-LFA, but for MPLS LDP. And last but not least, we have TI-LFA. Okay, so TI-LFA came from all this family of LFAs, remote LFA, and then TI-LFA. But TI-LFA is specifically targeted for use cases where we have SR-MPLS and SRv6. It's only targeted for those protocols. Okay. For LDP, for example, that also is common encapsulation labeling for many providers, we have remote LFA. Okay, remote LFA. That they are the same concept, they share the same concept, finding a backup path, but the calculation for the backup path and the process for calculating a backup path is different. TI-LFA has a broader scope for essentially achieve what I mentioned at the beginning, choose a backup path independent of the topology. Okay. And that's the main differentiation between TI-LFA and remote LFA and of course LFA. Okay, so that's the concept of TI-LFA and the family of LFA. Choosing a backup path is save time because we don't consume more time calculating after the link failure a best path, and of course installing into Ceph. And that of course improves the convergence side of the network. Another thing to mention as well is that TI-LFA comes into, it's a trade-off because it consumes more resources. When you insert a backup path into the Ceph, for some platforms it consumes more resources. For example, FEC or NCAP in iOS XR boxes, it consumes more resources. So this is another thing to take care about. We will not talk about that scaling in this video, but more about the functionality. But of course, when you are planning to enable this feature, consider your hardware capabilities of the box and what resources it consumes in the specific platform when you will enable this feature. Okay, so in this lab, we will just have these three devices. I will just go in quickly into that. We will have these three devices that you can see there. ASR9K 1, 2, and 3. So we have basically propagated everything in ISIS, and we have the loopbacks in ISIS and all the point-to-point links as well. So what we will do basically is to enable TI-LFA in ASR9K1. Okay, we will be looking constantly at the loopback 0 of ASR9K3. So we will monitor how our Ceph is and many things that we will check for TI-LFA with target of the loopback 0 of ASR9K3. Okay, so again, ASR9K1 will have 2 paths to reach out the loopback 0 of ASR9K3, and we will enable TI-LFA in this platform here. That is an ASR XRB 9K with the version 24.3.2. Okay, so I will just stop here, and we will just go to ASR9K1. Here, admin. We just put the credentials. And the first thing that we need to do for enabling TI-LFA is go under ISIS and enable some commands. But before that, I just want to show you how the network looks like. I just type show route, and there is here the route to the loopback of XR9K3. And my next hop is the gigabit 003. It's this link here that you can see over here. I don't have a backup path, as you can see, for this network, for this destination. So the goal will be to have the backup path and to see how it's installed into Ceph, and also in some show commands to verify TI-LFA. Okay, now let's check Ceph again. This is show route, so we check the RIP. Now we will check Ceph, which is the FIP, and here we see that we have, of course, the next hop as well over the gigabit 003, which is expected, but we don't have a backup path. Now, what we need to do to enable TI-LFA, we need to go to router, ISIS, SR MPLS, is my process of ISIS. Then I need to join to the specific physical interface. And under the specific physical interface, I need to type faster route per prefix first, and then per prefix TI-LFA. Okay? Here there are other things that I can enable, for example, remote LFA. I can enable TI-LFA only at specific labels like level 2. I can enable a tiebreaker, which are other options for calculating a backup path. There are many options there. I just wanted to show you the basic functionality of TI-LFA. Okay, so we will just go and enable TI-LFA. Under the gigabit 00 is the one that we enable here, and also under the gigabit 03. When you enable TI-LFA in your network, it's quite common that we enable across all the interfaces. Okay, that's a normal best practice. But of course, be careful with resource utilization, because you need to insert a route into the Ceph and FIP, and that consumes resources. So in my case, I enable to both interfaces. That's the way that you need to enable. First, you need to type per prefix, not directly to TI-LFA. That's the way of you need to configure this, and enable across all the interfaces that you want to have it. Now let's check show route, for example, again to 3333. You can see that now we have 2 paths. One that is the one that is protected, is our active one. When it says protected, it means that this path is protected, so this path is the best path. And the backup path that got installed is this one over the gigabit 000 here. Okay, so we have this as a backup path, and here is, of course, a backup path to reach out the loopback 0 of 3333. Okay, now let's check Ceph as well to that prefix, and then you will see that we see now 2 paths. Sorry, the protected path, that is this one here. Actually, yeah, this is this one here, and then the backup path, that is this one here. Okay, the backup path always will have a backup in there. Okay, so that will be the meaning of the backup path. Perfect. Now let's take a look into specific commands. Show ISIS fast route summary, for example. With this command, you can see which and how many prefixes are protected with TI-LFA. Okay, or basically which prefixes have a backup path in a short words. In our case, we have prefixes that are medium priority and low priority. So medium priority, for example, are 2, and low priority prefixes that we have in the device in our routing table is 1. How this is classified? Well, in my case, my loopback is /32. In this case, router 3. I will just put show route again. Show route ISIS. So my loopbacks, I have 2 loopbacks that are /32, so they are classified as a medium priority prefix. and the /24 that I have is classified as a low priority. So when we enable TLFA, there are these prioritizations of prefixes, because probably we want to enable only TLFA for prefixes that are critical or that are high priority. We don't want to enable TLFA for prefixes that are low priority, like point-to-point links, for example. So that's why this classification happens, so you can configure over the CLI and just enable TLFA for the prefixes that you want to have a backup path, okay? And you can classify those prefixes manually, okay? In my case, the /32 is being classified as a medium priority, so that's why it shows 2 here. But in normal network, the /32, if you have SR MPLS, for example, you would like to put that as a critical, because without that you don't have services. You can do that and you can enable TLFA in that. But we will take another video to explain this part more, okay? I just want to show you here that fast route summary, we have medium priority prefixes, which are my loopbacks, and there is of course the loopback of router 3, and we see this as a protection 100%. This basically tells us that we have a backup path for both prefixes, and here as well that we have a backup path for this prefix here, okay? So that's basically the show command that we can verify TLFA. There is another command that we can just type show ISIS fast reroute, and here we can see that there is a backup path for all the prefixes that I have in my network. I will just expand this a little bit to show you a bit better. So here we have, with this command show fast reroute, the loopback 0 of router 3, and we see a backup path enable, okay? Enable over there. So it means that the router, a part of installing the main path, it install also a backup path that is the target of TLFA. Okay, so basically with that, and specifically with this show command, show ISIS fast route summary, we can make sure that we have TLFA enabled for all the required prefixes. That was the session today with TLFA and what I wanted to show you. Next videos we will talk a bit more about this classification of the prefixes and how you can take advantage of that for real network cases scenarios. I hope that the information was also helpful for you, how to enable TLFA, how to verify, how to make sure that TLFA in reality works, and this theory around TLFA as well. I hope it was useful. Thank you very much for watching and see you in the next video. Bye bye.